Okay, lesson 1 about limits. So what is a limit? It's defining what is the function approaching as your input is approaching a certain value. So when we say a function, for instance this, we could state that our function is defined by that. So as we input numbers that get closer and closer to 5, what's happening to the y? So also when we say getting closer to 5, we're talking about coming to 5 from both sides, so from the positive and from the negative side. So let's just say we could graph something like this, and then you can visually see. Okay, so I'm just going to make my window bigger here. Let's go to 100. Okay, so here we have a parabola. So as we approach 5, we can see as we're getting closer and closer to 5 on the x, what is the height approaching? That's basically what we're asking. Okay, so first method is when we can use actual substitution and it works. So if we input a 5 in here, and we get 25 plus 35, which is 60. So that as we get closer and closer to 5, so for instance on here, if I'm moving my mouse, you can see me getting closer and closer to 5. Let's say if I start down there, if I get closer and closer and closer to 5, my function's just getting closer and closer to 60. Same if your mouse was up here and you got closer and closer to 5, you would get closer and closer on your y to a value of 60. Okay, so that's method 1 when your substitution works. Method 2, substitution will not work in here because if I substitute a 7 in for my x, I have a division by 0. Okay, so I'm going to show you a different method here. Just hold on a second. Okay, so I'm going to put in values that are close to 7. So I could go, I'm going to put a 6.9 in. Okay, so as I put a 6.9 in, 6.9 squared minus 49, and I get 13.9. I could go closer, 6.99. Okay, so this time 6.99 squared minus 49 is 13.99. Okay, I'm also got to remember that when I'm getting closer to 7, I'm getting closer to 7 from both sides. So from the other way, I'm going to get closer to 7. So I'm going to pick 7.1 and 7.01. Okay, so you can see me getting closer to 7 coming in from the right-hand side. Okay, so now that we got closer to 7, we can clearly see that we are approaching to a specific y value, so we are getting closer and closer to 14. So the limit of that equation as x approaches 7 is 14. Okay, method 3, obviously again substitution would be easiest, but it's not going to work because if you substitute a 5 in, you're going to get a 0 on the bottom, which we cannot physically divide by 0. So I'm going to try to eliminate a problem. So I'm going to try to factor this bottom. So x minus 5, x plus 2, if you factor it. So the limit as x approaches 5 of this equation, and now I can also cancel. So now the limit as x approaches 5 of 1 over x plus 2, now that I've eliminated a problem, I can actually plug a 5 in to this because it does not create a mathematical error. So now I would get 1 over 5 plus 2, which is 1/7. Okay, method 4, we are going to use analyzing what happens is our fourth method. Okay, so first one, x is approaching infinity. So we have to think about what's going on. So here we're squaring and here we're squaring. So that's the largest degree that we're doing. So think about 1 billion squared times 4 and 1 billion squared minus 3 billion minus 10. As you approach infinity, these almost become irrelevant, right? It's like kind of the idea of 1 billion trillion and 1, right? Like that 1 is so irrelevant because your number is so big. Okay, so these are going to go up at the same rate because they're both squared, but obviously this one is 4 times bigger at the same rate as that one is going up. And then these are irrelevant. Okay, so we can conclude, because these are going up at the same rate, 4 times bigger, that this is going to approach 4. Okay, I'm going to show you another way to do this. So I'm going to take my equation and I'm going to divide, or I'm going to times it all by 1 divided by 1 over. I'm going to divide it by x squared, everything. Okay, so if we take everything divided by x squared, so this is 4x squared over x squared over x squared. Okay, so this would cancel, right? And this would just cancel to be 1. Now, you can see that when you have a bigger number on the bottom, think about what happens, right? 10 over 1,000 million, whatever. The bigger number that you have on the bottom, this number is going to approach 0 because it's getting so small. So these are going to approach 0. So like I said before, that's why you can see they're irrelevant, because they're going to approach 0. So then we're approaching a value of 4. Okay. Next one. Okay, so now we're going to analyze. This degree is a second degree and this is a third degree. So this is getting bigger faster. Okay, so what happens when your bottom gets bigger faster is that again, like this, when your bottom gets bigger faster, your number gets smaller and smaller and smaller and you approach towards 0. So that means that we're going to have a limit of 0 here. So I could take everything and divide every single term by, let's say, an x cubed. So if I take everything and divide it by an x cubed, I can see what is going on. Okay, so this becomes 4 over x plus 7 over x squared, 5 minus 10 over x squared. Okay, and you can see here that anything where you have more x's on the bottom would approach 0, so this would be 0 over 5, which is 5. Okay, last one. Okay, now I look here and this is bigger, and it's going to get bigger faster as we approach infinity. Okay, so think about what's happening. If you're bigger number, you just get bigger and bigger and bigger, then you're just going to get bigger and bigger and bigger. Okay, so this is going to approach infinity. And I will show you a mathematical way to also do it. Let's divide everything by an x squared. Okay, so everything is going to get divided by an x squared. Okay, so that will be 0, 0. That'll be a 1. This would be an x. And that would be a 0. Okay, so that's what I would come out with if I was thinking about it, and if x is approaching infinity, then you're just approaching infinity.